Hello everyone, my name is Ashfaq Ahmed and I work in the field of structural biology and bioinformatics. A few months ago, I had covered a video like how to perform biological modeling with the help of AlphaFold3. I received many of the comments that can we dock all kinds of inhibitors or molecules, organic molecules, I would say, without protein? And my answer was no. But today, I will teach you that how can you perform molecular docking with any kind of organic molecule using AlphaFold 3. And it's just a fresh release or a fresh reproduction of the AlphaFold 3, and its name is Protenix. So let's have a look at how it works or how we can use AlphaFold 3 with the name Protein IX for molecular docking in our research. So the program name is Protein IX, and it's actually a trainable or a reproduction of AlphaFold 3. So there was a limitation in AlphaFold 3 that you can only dock certain number of ions or a certain number of um, organic molecules with AlphaFold 3. But now in its reproduction or its a new version, it's generated by another lab. Its name is Protein IX. That is that also use an advanced AI tool, and it can predict or it can model higher accuracy of protein structure because it actually uses the AlphaFold 3. But the good news is that with this method, we will be able to dock, I'm using the word dock, or to incorporate all kinds of molecules with a protein, including ligands of your choice, ions, DNA, RNA, or if you are interested in certain covalent modification or in or some protein modification, so you can do that as well. So let's see how we can do this kind of thing. And at the end, we will compare our results with the PDB structure to see how much accurate this protein IX provides the results. Okay, so this is my previous video, how to use AlphaFold 3 for biological modeling, and it is one of most viewed video from this channel. So today we are going to learn one step ahead. Okay, as I told you, this is a kind of new update. If I tell you it comes just a week ago or less than a week ago, so far they don't have a separate web server. So we will access that web server from the IP address. So how to access? You have to type 106.11.40:8000. I will also drop this link in the description section of this video so you can take it uh, from there also. Okay, enter. Once you enter, you will see this kind of thing, Protein IX server, and some brief introduction. I actually kept this introduction on my second slide, and it's free to use for all, for commercial and non-commercial people. So you can use it, you can download it and use it locally as well. But right now we are learning them from the server view. Okay, so click continue. Okay, this is your job ID. If you want to change, you can change it. Okay, use MSA. MSA stands for multiple sequence alignment. So if you want to use MSA in your prediction, you can keep it true, or if you don't want to use it, keep it false. Remember, if you use MSA, it will be a bit longer, but it will be more accurate. So I would suggest to use it. Atom confidence. If you want to use it, once again, it will be a bit longer, but it will be more accurate. So click true. Okay. Now here, email. So you have to provide your email because so far, as I told you, there is not a dedicated server. Therefore, we are accessing it from this IP address. So you don't expect like we will visualize our results here. No, they will send us our result to our email. So please enter the email here, whatever your email is. Now, then you have this tab, sequence tab. So in sequence tab, you can increase or decrease. For example, I'm using my one of my favorite sequence because I'm using this sequence in many of my videos. So NDM1. So it's okay. I'm using this sequence. This is the sequence, copy sequence of NDM1. So it's copied from here. I click here so you can see it's copied. Now come here and paste it here. Okay. Now, do you want to add any modification? Click here. What kind of modification you want to add? Just write like methylation, glycosylation, blah, blah, blah. But right now we are not interested in any modification. So click it here, delete it. Okay. From here, you can see copies. So if you want to model a dimeric, trimeric, or tetramer, or asymmetric units, I would say, or symmetric units, are uh, those kind of things. So you have to increase it 1, 2, 3 for tetramer 4. But right now I'm interested in a single protein. Okay. Now I want to add ions because I know this protein, it is present also in the PDB for EXS and many others. PDB IDs are available. So I know about this protein that it incorporates or it takes or it has two zinc ions. So in sequence 2, I would select here ions. Now, once I select ions, so how many ions I need? I need two ions because for the every NDM molecule or every NDM structure contains two ions in the aqueous pocket. So two ions. Okay. Now here I need to write the names of the ions. So you have to take care of it because if I write like this, zinc, so this is wrong. You have to write like this, CCD underscore zinc. So it's up to you. If you want to incorporate magnesium ion, then you have to write Mg here. If you are interested in zinc, then you have to write zinc. If you are interested for calcium, then Ca and so on. The third thing, I want to include um, any ligand. Okay. This is the most important thing. So first select here ligand smileys or ligand CCD. So I will teach you on the ligand smileys. You select this one, ligand smileys. Remember, the real structure or the 4EX structure, which I will compare later on, that contains L-captopril. So let's say we are opening a pubchem, and in the pubchem, I'm just taking a random I take ibuprofen. Brand name normally it is just kind of Brufen, NSAID, Sanid, and I don't know in your country what brand names are there, but the chemical name is ibuprofen. So if you see here isomeric smileys, so just try to copy this exactly like this. For example, okay, if I copy here and I paste it here, it's okay. But now also let me show you, don't make this mistake. For example, if you copy like this, you see, it will give probably an error. You see? Why? Because if you see here is a space during the copy. I dragged it here so I can see a space. So now how to fix it? Just back shift. Now there is no space and now it's done. So technically what we are doing, we are modeling our system for this protein having two ions of zinc, and the protein should be one chain, and we want our chemical brofen to be incorporated there or to be docked there. So this method do not need any kind of how to say the grid box and those kind of thing. It is more intelligent by itself. So let's see how will it works. And then if you want to add some covalent modification, so you can click here and you can covalent bond where you want to add a covalent bond and enter the atom names and blah 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 blah. But we are not interested here right now. We are actually interested to learn that how can we dock any kind of ligand or any kind of ion in our protein. So now click here, submit. Okay, it says verification failed because I did not incorporate in my email. So let's see, submit. You will see this kind of thing. Now you have to hit confirm. Okay. I will not hit confirm because I don't want to put an extra burden on the server. I had run this a little earlier, so I will lead you there. But before confirming, you can see this is your sequence. This is the second part that we are using zinc ions and how many? Two. And here are the count is one, ligand one, and this is the job ID, and MSA is true, atom confidence is true, covalent bond is nil, zero, and this is the email. And just click enter, submit here. But once you hit submit, so remember it will takes almost 10 to 15 minutes. Maybe a bit longer also, depending upon your job, your proteins, your setting. Also, I told you that these guys are working on it to bring a dedicated server, so things will be much more easier in in the future, in the near future, I would say. So far, then you have to wait for at least 15 minutes. Okay, so I run this job already and I got this results. And this was my job ID, this was my task status, this was my sequence, this was my about the ligand and the zinc and covalent bond was zero, blah blah. And then task output URL are um log URL, etc. So click here, output URL, and click this one, visit link. Now you will see a download here. Now here is our download. So it's here. I will cut it from here and will paste it in. It's already here, by the way. Okay. So, okay, replace. Now, um, we have to extract this and extract all, extract. So this is our result. Now, if you enter it, you will see three three JSON files and three directories. Now enter into the protein IX job, then seed, then predictions. So you will see some JSON file and some CIF file. Remember, your the files of your interest are the CIF files. So now we are going to open. I will use Pymol. Okay. Now in Pymol open and then download simulation here, protein IX, seed, predictions. Now Pymol itself will not read the JSON file, so you will only see the CIF files, and these are your files. So uh, ideally, the first one is the top ranked one. So click here, and for more information, you can also see the JSON 0 file for the scores and all those things. Okay, so open it. So this is our structure predicted by this program, and let me make it bigger. And wait, okay, okay. I needed to show you something white. Okay. Now, this is our structure with indium 1 with 2 zinc ion and with ibuprofen. Okay. Now, I'm going to load the actual 4EXS and which I kept already here. Um, this one 4EXS PDB. So now we have two structures. Let me, okay. So this one is the experimental one and it contains L-captopril. So the better is to align them. Now both the structures are aligned and the cyan one is a experimental one and the blue one is actually the um, predicted one. If you see here, like only the prediction part is available, this is actually the N-terminus part, which is missing in the actual structure. The actual structure starts from 42 and this one starts from 1. So you can also see here, this is the sequence. Now, if you see here, it starts from ME and the experimental one starts from 34 somewhere here, PIGS. So that's why you will not see this part is in alignment. The rest it's pretty much cool. You can see perfect alignment. Okay, you can also see the position of zinc atoms I think it's pretty much fine. Okay, now here if you want to see, the green one is the broken and the cyan one is actually the L-captopril. So apparently, or not apparently, you can see the ibuprofen has the exact pocket, and also the two hydroxyl or the two oxygens are penetrating towards the zinc ion. So that's an interesting result, and it means that from now on, you can perform docking of your biological system using AlphaFold3 with protein IX. Okay, that's it for now. If you have any question, please drop your question in comments. If you want me to bring some tutorial of your choice, please let me know. I will try to make that for you. And if you're liking my videos, please subscribe, thumbs up, and share these videos. In near future, I will bring such updated stuff for you. So for now, bye bye. All the best.